In this video, we're going to look at centroids and moments of inertia. And this is, these are some problems from part 1 of your exam 1 review. And I'm going to jump to problem number 4. This is asking for the centroid of the object and the moment of inertia about the x-axis and moment of inertia about the y-axis. So if you look at this object, it would probably be helpful to think of this as being like one big rectangle and then subtracting the circle and subtracting this triangle up here. So you could start with a big rectangle, subtract this circle, and subtract that triangle. And so let me do this on a separate sheet of paper. Let me sort of keep it visible. So let's maybe look at each individual thing that we have. So we have this big rectangle here. And it's 6 inches by 11 inches. Then we're going to subtract from that this triangle up here, this white space triangle. Let's do something like this here. And then finally, we're going to take out this circle. It's a 2-inch radius circle. And so we'll look at that as well. So let's look at each of these objects. First, let's take a look at the rectangle here. Of course, the area is just going to be the base times the height. Excuse me, this was 10 inches, sorry. This should be 10 inches right here. And so it's going to be the base 6 inches times the height 10 inches. So this is 60 inches squared. Now the centroid of this from, again, let's count this point as 0, 0 over here. The centroid, of course, is going to be right in the middle. And so the X bar is going to be 3 inches from this side. And the Y bar will be halfway up. And that will be 5 inches. And then if you look in the table, the I about the centroid is 1/12. And excuse me, this is the, say, from the X direction, X, I'll call it X of C to indicate that it's about the centroid, 1/12 the base times the height cubed. And that comes out to be 500 inches to the 4th. And IY of C is 1/12. Again, this time it's from this side, so we're going in this direction. So 1/12 the base times the height cubed. And that's 180 inches to the fourth. So that's all the stuff for the square or the rectangle. And then we'll have the triangle. The area is 1/2 the base times the height. And that's going to be 18 divided by, so that's going to be 9 inches squared. Then now for the X bar, we have to get an idea of where we're at. Of course, the X bar is always going to be, say, 1/3 from this side over here, 1/3 from the long side, or 2/3 from the point. So it's going to be, let's say, right here. And so from this edge here, it's going to be 2/3 of this, or 2 inches. So I just took 2/3 of 3 to get that. And then for the Y bar, it's going to be like 1/3 from this long side, or 2/3 from the bottom. And that's going to be 2/3 of 6, which is going to be 4. So it's going to be 4 inches up this way. However, if we look at our picture, we look at our picture over here, again, that's going to be this point over here. Notice for our X bar, it's 2 inches from this point here, but then we're going to have to add 3 inches because this point here is 3 inches from the edge. So our X bar is going to be 3 plus 2, which is 5 inches. And then for the Y bar, notice again, we're 4 inches from this point, but then we're going to have to add another 4 to get to this point. So it's going to be 4 plus another 4. Then if you look in our table in the back of the book, I of XC is going to be 1/36 times our base times our height cubed. And that comes out to be 18 inches to the fourth. And our IYC is 1/36 times 6, 3 cubed. That's going to be equal to 4.5. So that takes care of our triangle. Finally, we want the information with a circle. Of course, the area of the circle is just pi r squared. Which comes out to about 12.56 inches squared. And again, it's the centroid is right at the center of that. but we have to see how far the centroid is from the X and Y axis. So if we look over here at this picture here, you can see it's 3 inches from this edge. And it's 4 inches from here. And finally, for IXC, again, looking at the table in the back of the book, it's 1/4 pi radius to the 4th. And that's 12, also 12.56 inches squared. It's just a coincidence that it's the same as here. It's usually not going to be the case. And also IY is 1/4 pi to the 4th, 12.56 inches squared. So now we have all the information that we need, and now we can do some calculations with this. So we want to find the centroid. So we're going to have to, and maybe you even want to make a little table. That could sometimes be helpful. So if you have, say, all your objects here, let's say you have your rectangle, your triangle, and your circle. And the area of each one. Again, I've already calculated all those. And for it's 60 inches squared for the rectangle. The circle, excuse me, the triangle was 9 inches squared. And the circle was 12.56 inches squared. And then our X bar and our Y bar. Our X bar was 3 and 5. For the rectangle, for the triangle, it was 5 and 8. For the circle, it was 3 and 4. So now we're going to need our X bar times our area. So let's just write that down. And then we're going to need our Y bar times our area. So that's going to be, so our X bar times our area is going to be 3 times 60. It's going to be 180. And that's actually inches cubed. And Y bar times our area is going to be 300 inches cubed. This is going to be 45. And this is going to be 72 inches cubed. Then I'm going to need my calculator for this one. This is going to be 37.68 inches cubed. 4 times this 50.24 inches cubed. And finally, let's write our inertias, I, X, and I, Y. For each one, this was 500 inches to the 4th, 180, 18, 4.5, 12.56, 12.56. Now remember the centroid. So if you want, let's say the X bar is going to simply be these small X bars, or sometimes they'll put like a, you know, a wiggly line above this, but I'll sort of write that just to sort of distinguish it from the overall X bar times the area. So sum the X bars times the area divided by the area. Now we'll do the rectangle, which was 180. But now remember, for the triangle, we're actually subtracting it out. And for the circle, we're subtracting that out. So we're going to have to subtract those X bar. So the triangle would be minus 45. And the circle will be minus 37.68. So again, this was just the X bar times the area, but that's what we need here, divided by, and this should be like the sum of the areas, divided by the sum of the areas. So it's this. We subtracted the triangle because it was taken out. We subtracted the circle, and then we'll add up the areas in the denominator. And that's 60 for the rectangle. Once again, we're subtracting out the triangle. We're subtracting out the circle. $97.32. $38.44. I got like 2.53 inches. That's the overall centroid for the overall part. And for Y bar, want to sum up the Y tildes, summation of the area. And so once again, just look for the Y bar times the area. It's going to be 300 minus 72 because we're taking out the triangle, minus the circle, which is 50.24. Now the area is going to be the same. The denominator is going to be the same as for the X bar. But let me just write it down just to make it clear. But that's going to be the same. So if we sum these up here, got 4.624 inches. So that's those are the centroids. And then we want the moment of inertia about the x-axis. So again, remember, So for the moment of inertia about the x-axis, we're going to take all the moments that we had. So let's start with this one up here, the rectangle. So the I of x was 500 inches to the fourth, but that centroid was away from the x-axis. In other words, it was 5 inches from the x-axis, so we're going to have to use a parallel axis theorem and say that's going to be plus that distance squared times the area of the rectangle, which is 60. Remember, when we do the parallel axis theorem, this has to be the distance squared, and this is the area. And this is the moment of inertia over here. So again, this is all for the rectangle. And then we're going to subtract out the triangle. Again, over here, the triangle, the moment was 18 plus the distance squared. So we'll have to check for the triangle. It was, the centroid was 5 inches from the x-axis. Excuse me, we want the y-bar when we're doing this, because we're looking, we're taking about the x-axis, so we want the distance from here to that point, and that's going to be, once again, our 4 inches plus our 4 inches. So that's going to be 8 inches squared, then times the area of the triangle. Finally, for the circle, we have our 12.56 plus the distance of the circle from the x-axis, that's going to be 4 inches, times the area of the circle, like that. And that will give us our moment of inertia about the x-axis. And let me just calculate these. 25 times 60. And this all comes out to be 2,000 over here. And this over here minus 5 minus 213.52. And this comes out 1192.5 inches to the fourth. And that's going to be our answer for I of x. And our I of y, same idea. Do for the rectangle, do the 180. But then again, we have to see how far a rectangle is from the y-axis, and the center of it is going to be 3 inches from the y-axis. we're looking at this way, 3 inches from the y-axis to the center of our rectangle. So that's going to be 3 squared. And then the area of the rectangle was 60. Then for our triangle, the moment for the y was 4.5. And then again, for the triangle, the distance from the y-axis was 3 inches plus 2 inches. It was this distance here, 3 inches plus that 2 inches to the centroid. So we'll put that down. And it goes 3 plus 2 is 5, 5 squared. Then the area of the triangle is 9. And finally, the circle, moment of inertia for the circle was 12.56. And the distance of the centroid, the circle, from here was 3 inches. Then times the area of the circle. And let's put all this in our calculator. And so I'm getting 364.9 inches to the fourth. And those are our answers. Got our centroids up here. And our moments of inertia down here. Next, I'm going to go to the one where we need to do the integration. So let me go on to that and just mark this here. And so let's look at this problem right here. This is number 6 on your practice. So we want to find the I of y about the y-axis. So let's do that. So once again, usually what you want to do is, again, you can make another picture of this if you want. I'm going to maybe just work with this one here. I'm going to make a little rectangle. Remember, you make a typical rectangle in it. And because, again, it's on the x-axis, this is this width here is dx. And so once again, if you think what's the area of this strip, and that's going to be dA, is going to be the height times the width. And of course, the height of this thing is going to be y, and the width is going to be dx. Now we want everything to be in terms of x. Since we have a dx here, we want to change everything in terms of x. But we know what y is equal to. Y is equal to this: x over 4, x minus 8 times dx. And once again, let me just multiply things out. That's going to make things a little bit easier later. I'm going to just factor out this 1/4 since it's just a constant. I'm going to factor this out, and that'll make things a little bit easier to work with later on. And then I'm going to multiply this through. That's going to be x squared minus 8x dx. And now we can use our formula. So if we want IY, remember, if you want to find IY, you use the equation x squared dA. So we'll take x squared times this thing up here, and I'm going to factor out the constant again. So we're going to take x squared times x squared minus 8x dx, 1/4 x to the 4th minus 8x cubed dx. Again, all I did was take our typical area, multiply by x squared, because this is the formula you use for I or y. It's always going to be x squared times a typical area, and we have that. And now the only thing we have left to do is find our bounds. So we have x over here, so we want the bounds on x. Now the way this is set up, we have positive x here, negative x here, y here. So it looks like we're starting at -2 and going to 0. So our x value goes from -2 to 0. So just go ahead and integrate. 1/4 x to the 5th over 5 minus 8x to the 4th over 4. And we want bound 0 minus 2 to 0. Then we go put our bounds in. So it's be 1/4. Now our upper bound is 0 here over 5 minus 0 here, which that's always nice. And our lower bound, 1/4, and there's going to be -2 up here, -2 to the 5th, divided by 5. And over here, there's going to be -8. Actually, we can make this 2, can't we? 8 divided by 4 is 2. To the -2 to the 4th over 4. And we can simplify this and to put a -1/4 in front. And again, this is -2 to the 5th, because when you take a negative to an odd power, the negative stays. And then 2 to the 5th is going to be 32. And then this is going to be a positive 16 times 2. Do -2 times 16 divided by 4. And let me see what we have here. There's going to be 32 divided by 5. Plus 32 divided by 4. And I'm just checking my arithmetic here, be sure I did everything correctly. 4. Like this. Oh, I see. I see where I made my mistake. Over here, this 4 should be gone. Sorry. This 4 right here should be gone. This should be, because I canceled 8 and 4 and got 2 here. And so this should actually be 2 times 16. Because I'd already canceled that 4 out when I took 8 divided by 4, got 2. So let's put that. So we have here 2, just 2 times 16. So now let's try. We have -1/4 times -38.4. And that becomes a positive. And so we get 9.6. And it doesn't say the units. So I'm just going to say maybe it's inches to the 4th. But the units aren't given here. So we can just leave that out. So that's the idea how you would do it. The most important thing is to get this set up, your rectangle set up. Let's try the other one, the other problem, which was this one, number 7. And it's going to be done in a very similar way. And you could make a little rectangle in there. Yeah, once again, one's IY. And so again, we need the area of that strip. And once again, since this width is on the x-axis, this is dx. And again, we want the height, which is y, times the width, which is dx. But again, because we have dx, we want everything in terms of x. So we want to replace y with what it is equal to. Like that. And just as before, IY is going to be equal to x squared dA. So just put our dA in here. So x squared 2x to the fourth dA. Which is equal to 2x to the sixth dx. I'm sorry, this should have been dx over here. And so once again, look at what your bound should be. Here's the x-axis. This is a positive x-axis. We're starting at 0 going to 1. So make that 0 to 1. And just integrate. So 2x to the 7th, divide by 7, 0 to 1. To 7, 1 to the 7th is simply going to be 2/7. Once again, no units are given to them. Just going to call it inches to the fourth.